Well, the first two questions are pretty simple, but so I actually will write it 23 over 15. I'll actually write it like this. And then finally, I'll write it like this. That's a 5, by the way. Oops. So we're going to go 1, 15, what is that? 8, as decimal, it allows us to bring a 0 down. What is that? 5. Just lower this a little bit. 5, yeah, looks like that. 75. 5 left over. Let's bring another 0 down, see how far we can go. This looks like a 3, 45. Well, now I know it's going to be repeating. So this should be both a positive and a positive, so 1.53. Right. Second one. So I write in the three manners, 3 ways, different ways, just for you to understand that it can be written 3 ways. Okay. Again, 0 doesn't go into 14, so let's add a 0, add a decimal, and that looks like 6, 5. I'm gonna say 5. 27 times 5 is 135. Yeah, 5 left over. Let's bring a 0 down. That's not gonna work. So let's bring another. Oh, sorry. That's 1. 27. 23 left over. Bring a 0 down. 230. 7. Maybe 8. 8 looks like a number. What is that? 216. 14 left over. 27 times 6? No, 6 too much. It's going to be 5 again. So times 5 is 135. And I hope you realize, look at, I'm going to highlight this. This is starting again, and this is starting again. So I'm just going to continue a little bit more. Maybe you'll see it. Right? So this whole sequence is going to start again to 50, to 230, to 40. So we know it's going to be 0.158, 158, and then 158, and so on and so on. So again, another repeating decimal. By notation over the 518, because those are the 3 that repeats. Difference between 12. Okay, so let's set that to x. Right, so we're going to multiply this by 100 on both sides. And again, I just want to show you what happens when you multiply that by 100. So the decimal is going to move 2 over, so we're going to get 1,234.34. Right? So if I multiply that by 100, 1.234.34. The reason we multiply by 100, it allows us now to subtract, and we can get rid of the repeating parts. That goes away. 100x minus x is 99x. This is going to be 1222. Divide both sides by 99. Yes, we can simplify this, but I know it's too early to simplify. Let's see. The bottom we can divide by 3. The top, 4, 7. It's not divisible by 3. So this is going to be what, like 11, etc. 12 and something, and we're not gonna. Okay, so depending on your quiz, if it says simplify, then you would simplify. I'm just not going to. Oops, oh, I need that number, sorry. Okay, so it said, oh, maybe I do have to simplify because it says find the difference between 12.34 and 851. So one of my numbers is 122 over 99. Okay, so that goes away. And over here, let me erase this because I need the second number. I just completely forgot. The other one is 8.51. Let's set that to x. So x equals 8.51 bar. We're going to multiply both sides by 100x, and then again, I'm still going to show you that 8.51, 5, 1, 5, 1 forever and ever. If you multiply that by 100, right, you know the decimal is going to move over twice, so we're going to get 851.51 bar notation. Again, that allows us to get rid of this. We get 99x equals 843, right? 843. So divide both sides by 99, and x equals 843 over 99. Now we want to find the difference between both of them. What is that? So we're going to find 12, 12, 12 over 99. And good thing I didn't change it to a mixed number. We can easily subtract these two. And 1, 2, what is that? 1, 2, 2, 2 minus 843 equals 379 over 99, which is, let's see, 3 and 7 is 10, 19. Still not divisible by 3. But we can, this time it's easy to simplify. 99 goes in that 3 times, and it's going to be 82 over 99. Okay, pretty sure. Yeah, that's right. That's that. What's the next one? Evaluate. Okay, so we have 2.5 minus 2 over 15 divided by 5 over 12. Think about the shortcuts you could take here, So that's one of the fun things, how to make this, how to take shortcuts. And it's not about multiplying and subtracting right now. It's changing, manipulating these numbers into something that you can manage a little bit easier. So it's negative 2.5 times negative 2 over 15 divided by 5 over 12. So order of operations, we have to take care of these two first. So because this is a decimal and this is a fraction, I'm going to change this to a fraction. Probably make my life easier. That's a negative, by the way. Take care of these two. And if you wanted to, you can even, take that division and change multiplication and use 12 over 5. Okay, so now, because everything is multiplying, right, you can definitely, it's even shorter now. See if you can simplify anything from the top and bottom. So there's quite a few things you can simplify here. That 5 can go away. This becomes a 5. That 5 can go away again, and this becomes a 3. The 3 and 12, 3 is 3, 12 divided by 3 is 4. That 4 divided by 2 is 2, 10 divided by 2 is 5, and that's about it. So negative times a negative times a positive, which is going to give me a positive. And on top I have 2 times 2, which is 4, and at the bottom I just have 5. That's my answer. Again, manipulation is what I want you to practice. Right. Determine the sum. I don't think there's any manipulation here. Ugh, yuck. So we can change this to an addition, which is probably going to look much better. I have a preference to, in this case, change it to an improper fraction. 18, 26 over 9, negative, plus 40, 47 over 8. 72, sorry, this is negative times 8. Right, so we can get 48, 208, and then times 9, and on top times 9 again, so 3, 6, 42, that's what I'm getting. So it's going to be positive, so I mean, think about this. I mean, if I could just cover, so just focus on the numerators, right? It's 423 positive minus 208, you get 215 positive. And you can change that to a, a mixed number if you so choose. No, they can't simplify it, not divisible. Bottom is divisible by 3, but the top is not, so that's pretty much it. I think it'd be like 2 and 99, sorry, 2 and 71 over 72, something like that. And again, again, don't quote me because I'm not actually doing it. I'm moving. Next one, 4/5 minus 3/7 divided by 1/20 minus 0.5 bar notation, which I'm going to change right here. So that we can go like this, right? We can multiply both sides by 10, and that's going to be actually move the decimal 1 over. It's going to be 5.5 bar notation. If we subtract, we get 9x, and we get 5, and x equals 5 over 9, right? Now we can divide both sides by 9. So we just write 5 over 9. Makes my life a little bit easier. Let's see if I copied correctly. All right, so on the top here, I'm going to find the LCM, which is 35. This is going to be 28, and this is going to be 15. I can write everything over one fraction. It's the same thing. You know what? Let me just take this to the side. So because I don't. So let me take. So I'm focusing on this part right here. All right. So 28 minus 15 is 17. No, 13 over 35. Right. So I can, and then I'm gonna write that over 120 minus 5 over 9. Now that I'm done with this part, that part is gone, I can focus on these two, this section right here. And that section over there, let me erase this, just move that, okay, erase that. It's, take that to the side, it's 13 over 35 multiplied by the reciprocal, right, divided by 5, you get, I don't know, 4, divided by 5, you get 7. You get 52 over 7. So that whole thing becomes 52 over 7, and I can erase that. Well, not many mistakes I make. 52 over 7 minus 5 over 9 is just a simple subtraction problem. Again, the LCM is going to be 63 for both. So this is going to be 35, and then times 9 here is 18, 468. And we get something over 63, 433. Okay, which is, let's see, not divisible by 3, so again, just becomes a mixed number of whatever that becomes. Negative 2 to the 4th, oh, well, finally. Multiplied by negative 2 to the 4th power minus 1 over 1 plus 1 over 1 plus a half. Yikes. All right, so let's take care, I mean, it really doesn't matter. Remember, there's multiplication happening here. Let's do this. Let's do this section over here. Okay, because so careful here. It's that minus sign here. It's not being affected by the 4th power there. So it's just 2 to the 4th power. 2, 4, 8, 16. So that ends up becoming 2 to the 4th power 16. That with a minus sign becomes negative 16 times this part here. On the other hand, it's negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is 4 negative numbers multiplied give you a positive. So that's going to give you 16. We multiply both them. 16 times 16 is a number 256, and it's going to be negative. So that whole thing becomes negative 256. Done. That was easy. Minus, and now we have to focus on this section. Well, we've done a few of these, and by now you know. I'm going to take care of this part first. Well, that's simply 1.5, right? So I'm going to take that, and erase that 1 plus a half, and write 1.5. Now, 1.5 as a mixed, improper fraction can be written as 3 over 2. And that's what I'm going to write over here, 3 over 2. Now we're going to have, now if I want you to focus on this, that is 1 divided by 3.5. So, okay, so let me, and then 1 divided by 3.5 looks like this, right? That's the same thing as 1 times the reciprocal, which is 2/3. And 1 times 2/3 is just 2/3. So all that I'm going to erase. Right, 2/3. That equals 2/3. So, and if I add, and then, that equals 2/3. And what's 1 plus 2/3? 1 plus 2/3 is just 1 2/3. And if I change that to an what do you call a improper fraction, it gives me 5/3. Yeah. And now I'm going to slowly replace that and put 5/3 here. Now I get to focus on these two. And one that basically says 1 divided by 5/3, which is the same thing as 1 times 3/5. So that whole thing becomes, and 1 times 3/5 is just 3/5. So the whole thing becomes this. Okay. Next, if you want to change it to a addition problem, you can. So you get that plus negative 3/5. So we're adding two negatives. We're going further to the left on the number line. So there's not much to do here. It's just negative 256 and 3/5. Yeah, that's it, really. Here's a playground. It's a rectangular playground. The area was, again, 726 and 3/4 units feet squared. And then the width is 20.5. So let's call that 20.5 feet, not feet square. So we're looking for this measurement. Well, area equals length times width, right? This is given to us. The length is our unknown, and the width is 20.5. And again, go back to your equation, your 6th grade equation days, and that's no different than I showed you than I don't know, than that, right? Remember, it's an equation. The idea is to keep things balanced. So whatever I do to one side, I must do, and I want to isolate. I want this to look like that. In order to do that, I'm going to do it using inverse operation of multiplication, which is division. I divide that by 3. 3 divided by 3 is 1. 1 times a is a. Therefore, that's how I get my a. And on the other side, I have to repeat the same process. 15 divided by 3 is 5. So that process is what you do here, except that it's fractions. Big deal. So again, think about the idea here. It's divided by 20.5, right? And I divide this by 20.5. That is definitely going to go away because 20.5 divided by 20.5 is 1. So my length is isolated, and then I have to do this mess over here, which is, it's a little work. So let's change this to improper fractions. Okay, so 726 times 4 is, 726 times 4 is 2,904, and then to that I'm going to add 3. It's going to give me 2,907 over 4 times, right, I'm going to use the reciprocal. Let's find out what 20.5 is as an improper fraction. It's 41 over 2, and the reciprocal of that is 2 over 41. And this simplifies, so I end up getting 2,907 over 82. Okay, so 2,907 over, what is that, 82? And if you simplify that, you end up getting that, if you change that to a mixed number, you get 35, 37 over 82. And that's the length of that playground. Now this question, it's interesting. So we have 3 boards. It really depends how you read it. Each of these boards measure what do they measure? 8 feet. So I'm just going to write 8 feet. Okay. Now, and you want to divide, you want to cut boards that are size 2 and 3 feet. So you want to make them in these. Here's a problem. The problem is that some of you might read this as, here's 8 feet board, right? And you attach the second one, and you attach the third one, making one long board, and then you can cut, obviously, 2 and 3/7 over here, another 2 and 3/7, another 2 and 3/7, another 2 and 3/7. And notice that here, when I cut this part over here, I'm assuming they're connected, right? 2 and 3 sevenths, 2 and 3 sevenths, 2 and 3 sevenths, 2 and 3 sevenths. So you might get an answer this way, assuming that's one long board. Now, what if they're not one long board and you have 3 of these separate? So I'm just assuming here, right? So let's say I can cut 2 and 3 sevenths over here, and I can cut 2 and 3 sevenths. Do I have room? Sorry, let me just make this a little tighter. And I cut another 2 and 3 sevenths here. Change colors. And I cut another board that's 2 and 3 sevenths. Do I have room to cut another one for 2 and 3 sevenths? You know, so therefore for this board I can only get 2 of these, two boards that are 2 and 3 sevenths. So in here, same thing. I have one. Change colors. I have another one. You know, what if I don't have room for another one? So in this case, I would have 1, 2, 3, 4, and then on the last board, the last big board, I can cut 2 and 3 sevenths, 2 and 3 sevenths, and let's say, just again, this is an example, that I can't because I don't have enough for another 2 and 3 sevenths, so it's my answer 6, because on this board, on this big board, I was able to cut 2 pieces, this one 2, the last one 2. So how would you read this question it's extremely, extremely important. So, and it doesn't say, so it's an interesting question because of that. So let's try and do 8 feet divided by 2 and 3 sevenths. So if I have one of those boards, let's say that big, the first board, and I divide it by 8 and 3 sevenths. Well, first of all, let's change 2 and 3 sevenths into a mixed number. And that's going to be 17 over 7. Sorry, yeah, 17 over 7. So it's going to be 8 times 7 over 17. Can I simplify now? So I get 56 over 17, which I'm going to change to a mixed number. So how many boards can I cut? Well, let's see, 17 times 3 is 17 is 51. So 3, 5 over 17. So I can cut with an 8 feet board, I can cut 3 pieces. And let's see if I can. 1. Here would be not. I'm going to change colors. My second one, change colors again. My third one, and how much would I have left over here? Here's my 5 and 17 left over. So if I repeat the process, I can, on this board here, I can get 1, that's 2 and 3 feet. I can cut the second one. I can cut a third one, and I'm going to have this left over, 5 and 17. Oops, green. Right, and if I repeat the process at the bottom, 1, I'll take the red one, then I'll take another board that's 2 and 3 sevenths feet, but then I'm going to have this left over, 5 and 17. So I can say that I can get 9 boards, and I can add 5 17ths by 5 17ths by 5 17ths, which gives me 9 boards. 9 boards of 2 and 3 sevenths feet length, right? Oops. 3 feet length. And then how much left over? Left over is 5 17ths plus 5 17ths plus 5 17ths, which equals 15 over 17. That's how much left over. If you do it this way, right? Where the boards are not united. Now, if the boards are united, and I need some room here. Some board united. Okay. 2 and, what is it? 2 and 3 sevenths. Okay, right, so this is what we want, 2 and 3 7 boards. So now if the boards are united, and if it's one long board, right? One long board, which I don't think that makes, and it's, so that therefore the length, the total length would be 24 feet. So imagine if you could put all these 3 boards together and, I don't know, somehow sand it or glue it and make one big long board, that would be a different question. So now you have 24 feet divided into 2 and 3 sevenths. So how many boards of 2 and 3 sevenths can you make out of 24 feet board? So 24 divided, and we know already that 2 and 3 sevenths is 7 over 17, so I'm just going to take that and go like this. 24 times 7 is 168 over 17. 17 times 10 is 170, so this is going, so 17 can go into 168 9 times. Oops. Right, 9 times, 2 left over, and 17. So with this method, I can make 9 boards. Just separate. If it's one long board of 25 feet, I can make 9 boards, and how many left, and what's left over? I'm interested to see which route you guys took. Nine's just literally a matter of what do you call you changing units, yards. Okay, so 1 yard is 3 feet, and 1 foot is 12 inches. So it's just a matter of you choosing which what do you call what unit you want to work with. Well, it says that you have this much yard, and how much she used, and she started with how much is left over if in feet if she started with 186. So this is what she started with, 186.76 feet of string. Okay, and then from that we're going to subtract minus 2.5 yards of blue, yards, 78.35 feet of green, and that's already in feet, so we don't have to change that, minus that, and then the 900 inches, minus 900 inches of what color? Of pink. So what you have to do is obviously change this one and change this one from yards to feet. So I'll do that over here. So again, 22.5 yards. We want to change it to feet. Just multiply that by 3. We get 67.5. So this becomes 67.5 feet. That's okay. This one, 900 inches. And again, what do we want to change? We're going to change it to feet. So and divide by 12. And you get 75. This is 75 feet. So nothing to this, right? Divide by 12, you get 75, which is 86. Sorry, 84. 90 minus 4 is 60, and then 12 into 65 times, and that's how 12 feet. So now all you have to do is, subtract 186. So literally, our problem becomes 189.76 minus 67.5 in feet minus the 78.35 in feet minus the 75. And I think, right, is that, this is one of the problems that minus 67.5 minus 78.35 minus 75. You end up with negative here. So this was, obviously this number should have been higher. But if you got negative, it's okay, because obviously when I made the question, I should have used a higher number, but that is the answer. Okay. Last year, the heaviest pumpkin was 2,222. Tammy wants to break her record by 1 1/5 as much. Then she wants to use 3/5 of that to make pie. How many pounds of pumpkin will she make? Right, so I think we did this. Here we go. And from that, I'm going to multiply that by 1 1/5. You can leave it as a decimal. You can change, so it's really up to you how you want to multiply this. Times 1 1/5, and then times 3/5. So let's see if there's an advantage of 2,222 times, what is this, 5. 6 over 5 times 3 over 5. Is there an advantage doing fractions? Can I simplify anything? No, doesn't look like I can simplify anything. So this would be just 25, and on top it would be 18. 18 times 2,222, which equals that much. And obviously, we're going to simplify that. That one needs to be simplified. And we get 1,599 point something. I'll get that number for you. 1,525 and 0.84. Okay, if you left it as a fraction, 84 over 100, and you can simplify that. Okay. Here's a rectangle. The length is 1 7/9 inches. The width is twice the length, so this is 2 times 1 7 over 9. And then we want the area and the perimeter. Okay, so I'll leave it as a fraction. Let's change the width here. And 2 times 1 7/9. 2 times 9 times 1 is 9, 16 over 9. And that's 32 over 9. So I'm going to write 32 over 9. Right, and then over here, I'm going to change this 1 7/9 to 16 over 9 and leave everything in terms of nines. So what do we want? The area. So the area is simple, right? So area is length times width. So we multiply 16 over 9 times 32 over 9. Can I simplify anything? No. And we just multiply and we get 81. And that gives you 512. And obviously you would change that to a mixed number. You can knock yourselves out and do that. And then perimeter is just adding all the sides, right? The lengths of each side. So if you were going to take a walk around this particular shape, what's the distance that you just covered? So it's 32 over 9 plus 32 over 9 or times 2, however you want to write this. All right, so what is this? The perimeter. Okay, so it's 32 plus 32 plus 32, which is 96, sorry. 96 over 9 inches. This one is, sorry, inches squared. Okay. I need to make 2 videos, and I only have 4 more questions, so I'll attach part 2 later.